Okay, what did you?
Okay, so let's chit chat about these magnetic fields.
I don't
So
know why I decided I didn't want to do that.
this is also ability of your visual, of your ability to almost think in a three-dimensional way. So there was much discussion about question 30 and which direction that was. So if you look on question 30, okay?
I said
So the northern point of the compass points towards the current.
so where's,
Towards the current. The northern point.
remember this whole deal. It's going to split this area.
right? So, in terms of like being successful in this, because there's two versions of the right-hand rule. This is the simpler version. We're going to use the more complex version of this thing today. So, if you, let me try and draw this like three-dimensionally. So imagine here's the wire like this. The simple part of it is, and when we say current, we mean Ben Franklin current, okay? So the current's going in this direction. So then around this thing, so imagine a series of rings that are around that wire, okay? And they're all symmetrical. And the value of that magnetic field
There's nothing between A and C.
is mu sub naught I over 2 pi r. So here's the deal. So what this is telling you is the magnitude, all this tells you is the magnitude of the magnetic field. So clearly, because you're dividing by radius, and it isn't radius squared, you're just dividing by radius. So the closer you are, the stronger the magnetic field is going to be. The stronger the current is, the stronger the magnetic field is going to be. So mathematically, that isn't the challenge. You can plug numbers into the calculator. The challenge is what's going to be that direction, because that's going to drive today. Because today we're going to talk about what happens when you put moving particles in a magnetic field. So here's the current, and it's going in this direction. So you take your right hand, hence the term right-hand rule, and you wrap your fingers around like this, okay? So that field, imagine that you have a series of circles or donuts that are around that field where the current or the wire is in the middle, okay? So the trick is, what's the direction? So how all magnetic fields are laid out. So when you look at that compass, and it had the little arrow on it, okay? And then one of those is darkened. So that is showing you the direction of the magnetic field. So if you look on question 30, right away, which two can you eliminate as potential answers?
B and D.
B and D. It can't be B and D, because that has the magnetic field running parallel with the wire. So it cannot be B or D. It cannot be. So that only leaves you A or C. So, but this is where you kind of have to read the magic code. So since the current is going in this direction, and you wrap your hand around like that, so that magnetic field is going in that direction. So that's why the answer to 30 is C, because that's the direction that the field is going, and it's going to line up with that field. Okay? Does that make sense? Because you've got to be able to do that. You have got to be able to do that. Now, when you get to like a question on 30B where you want to find the radius. So you can add, if you want to, there's a little bit of a mathematical trick that you can do. So if you look at that mu naught value, that's technically 4 pi, I hate this pen, times 10 to the minus 7th So that's that mu naught value. So if you have like 2 pi r, if you want to get a little bit clever, since that's 2 pi times 10 to the minus 7th, you could actually like cancel that out and just make that 2 pi times 10 to the minus 7th. So it just saves you a little bit of steps, so then you don't have to multiply by 2 pi down below. It doesn't make me any difference, but trust me, if you're doing these calculations by hand, that's a cool step to do, because then you don't have to, that's just one less calculation you have to do by hand. So you can just get that to cancel out. On number 2, that radius should involve a bunch of 4s. Like the numeric value and the magnitude if you're in meters. Just saying. Okay, anything else? Once, twice, sold. Get that in.
You good?
Half a second, but then yes.
Danny, stop you on the camera. We're gonna go to the back.